This is our second lesson in algebra, and we're going to talk about two of the exponent laws, the product law and the quotient law. Let's do a recap. We did this on our last lesson. Remember the different forms. The first one is called exponential form because there's an exponent in it. 5 times 5 times 5 is expanded form, and you remember what 125 is? It's evaluated form, because remember, to evaluate means to find the final answer as a number. So we're going to talk first about the product law. Let's see what that is. First, let's simplify without evaluating. So we're going to expand this all out first. When we expand it out, we have 5 times 5 times 5 for this cube, and then for the power of 4, we've got 4 of them. So that's expanded. And then I just drop the brackets and it looks like this. So we've got all of these 5s here, and of course there's a more compact way of writing this in exponential form. So I've got to count up how many 5s I have in here in total, and I've got 7 of them. So let's just do a few quick examples more like that. The first one's done for you, 3 to the power of 2 times 3 to the power of 4. So I've written out there's 2 3s there, there's 4 of them there. Altogether that makes 6. So what about the second one here? There's all the 4s typed out, 3 of them in the first bracket, 3 of them in the second bracket. So how many is that in total? There's 6. And so on. 6 to the power of 4 times 6 to the power of 1. How many have we got? Now I hope you're seeing a pattern here. There's 5. What about all these 2s? I've got 3 groups of 2s there. How many 2s have we got in total? This is going to be 2 to the power of 9. Now, are you seeing the pattern? Because we're coming up with a law here. We're going to figure out a law. Now for the k's, there's all those k's. They're kind of hard to tell because of the x's. I don't know why this line is black here. I don't know what happened with my chart. Just pretend it's blue like everything else. And we get k to the power of 8. So if we take this together, do you see a pattern? Can you come up with, if I just give you this part, can you jump right to the answer without having to do the expanded form? Can you get right to the answer here as a single power? So here's the product law. The product law says that when you have a base with an exponent and you're multiplying it by the same base, x, right? All of these examples, 3, 3, 4, 4, 6, 6. We didn't have 3 to the power of 2 and then 8 to the power of 4. The bases have to be the same. Then all you do is you add the exponents together. So if I go back to this first example here, if I just take this exponent 3 and this exponent 4 and I add them together, I'm going to get 7. So back over here, let's just look at this one with the 6 here. If the base is the same, I have a 6 here and a 6 here, the bases are the same, so I add the exponents, 4 plus 1. That gets me right to my answer of 6 to the power of 5. So that's the product law. It's pretty straightforward, but you have to memorize that law. And the important part that you have to remember is that you have to have the bases matching. You can't have different bases or the law doesn't work. So that was our first law out of 2 laws today. Here's the second one, it's the quotient law. And if you can think ahead, you might already know where I'm going with this before I go through my whole explanation. It simplifies a single power without evaluating. So I'm going to write this as division this time. So there's my 7 3s all along the top, and there's 3 on the bottom. So the next, this one's got kind of a unique property I want to talk about, and that is that -3 over -3 is equal to 1, right? This is exactly the same, it's equal to 1. So what I'm going to do over here, I'm going to go and I'm going to take, let's say, this -3 with this first -3. I'm going to cancel them off because they're going to turn into 1s. I'm going to put little 1s here. I don't need to put the 1s because canceling implies a 1 is left over. So those are gone now, which means I can also get rid of these 2. They also will cancel it. Actually, let me change colors with those 2 so you don't get confused. So this second -3 and this -3 cancel out. I don't have to put them in order. I could take the last, or this middle -3, cancel it out with this -3, and they both turn into 1s. So what have I got left here? So how many, I've got all these -3s left on the top. but I've got none left on the bottom. So my answers are these 4 -3s, and a more compact way to write that, of course, is -3 to the power of 4. So let's try a bunch like that. We're starting with our 5. So when we divide or we cancel, so if I were canceling this 5 with this 5, one would be on top, one would be on the bottom. Cancel, cancel. So all I have left on the bottom is a 1. If you look back up to the question I did just above here earlier, all these 3's canceled out, all of them. So I have nothing left in my denominator. My denominator is just 1 now because all the 3's are gone. So that's why over the line below here is really over a 1 because there was nothing there, and I don't need to write a denominator of 1. So all I have left on this first one in the chart, I've got this 5 and this 5, which is 5 to the power of 2. The instructions say single power, so I'm not going to write that as a 25. I'm leaving it as 5 to the power of 2. Let's look at the next one. We've got 7 to the power of 4 divided by 7 to the power of 1. So that's 4 7's here divided by 1 7. So this 1 7 can cancel with one of these. That leaves me with 3 7's in the numerator still. How about the 10's? I think you're starting to pick up on my pattern here. Here are 6 10's divided by 4 10's. So imagine these 4 10's all below these 6 10's. All 4 of these can take out 4 of these. That means I will be left with, oh, that should be 10 to the power of 2 there. Sorry, typo. Let me fix that. 10 to the power of 2. Next one, 7 2's divided by 6 2's. So you can actually, if you're writing this along, if you're filling in your handout and you're filling all this in, you can do all the canceling, you can draw the lines through and cancel, and you can see what you're left with. You're just left with a 2 to the power of 1, which is the same as 2. This is the only case where we would write it, as evaluated form. If you have 2 to the power of 1, you can write it as 2. Again, this second last line of my chart I don't know why it's a double line. Just imagine that's a single orange line. Last one. P to the power of 8 divided by P to the power of 5. So we've got 8 of them here, 5 of them here. When we cancel, what are we left with? P to the power of 3. So you see a pattern here? I hope you do. What is the quotient law then? What is the rule? When our bases are exactly the same and we're dividing them, what do we do to the exponents? Instead of having to write it all out, what's a faster way to do this? There's our quotient law. We subtract the exponents. So if you go back to any of these earlier ones, like the top one here, let's look at this one. All I needed to do, instead of writing out all this expanded form, and I didn't need to do all that, all I needed to do was write 5, that's my base. And my exponents are 5 minus 3. That's all I needed to do, 5 to the power of 2. Let's do some examples. And it's important when you're using these laws, again, the terms have to have the same bases. So if they don't have the same bases, don't be tricked. You can't continue on. Example 1, write as a single power. So you're filling this in on your sheet. So my common base is an 8. My base matches, so I can put an 8 once. I only need to write it once. And now here's my exponents. I have a 5 and I have a 2. And when I'm multiplying, that means I'm going to add them, 5 plus 2. So I have 8 to the power of 7. And looking at the instructions here, it says write as a single power, so I don't need to evaluate. I don't need to get out my calculator and figure out what 8 to the power of 7 is. And if the question did say that in your homework, you certainly can use your calculator for a big question like that. Next one, m to the power of 6 times m. And everyone, I hope, is in the habit now of starting each line with an equal sign. So we have m is our common base, so I only need to write it once. What are my exponents here? So I'm going to be adding my exponents. 6 plus what? What's here? A 1, an invisible 1. There's always an invisible 1 on every term. So this is m to the power of 7. Now some of you are thinking, oh, I get it. I'm just going to jump to the answer from now on. You will be able to, But for now, you need to show me your work. You need to show me what you're doing. It's just an extra 5 seconds to write this middle line, but it has to be shown for now. Next one is our same, those bases don't match. So we don't have matching bases here. This is -3/2 and this is -3/5. They're not the same. So I can't write them as a single power because they don't match. And the textbook always throws these ones in here. They look almost the same and you kind of don't, if you don't pay attention, you would have maybe written a power of 9 to something here, but they're not the same. And this is multiply, remember? That's multiply. So this one, we can't go any further. So to write as a single power is not possible because our bases don't match. So that one we can't do, and there will be some like that. So just keep your eyes open for those kinds of questions. Next one, do our bases match? Yes, they do. They are both a 1.7. And the exponents, what are we going to do to the exponents? We've got an exponent of 6 and we've got an exponent of 2. Are we going to add them or subtract them? Subtract. So this is 1.7 to the power of 4. Next one we've got is do our bases match? Always look for that first. They do. And the base isn't just a -2, it's the whole bracket set, -2. That's the base right there. So my exponents, my first exponent is an 8. I'm going to write that down. Then I'm going to subtract a 6. Then I'm going to subtract again a 2. So this is -2 to the power of, so 8 minus 6, that's going to give me 2. 8 minus 6 is 2. 2 minus 2 is 0. The question says write as a single power, so I can stop here even though the answer to this is actually 1. The question said write as a single power, so this is, you can stop with the -2 to the power of 0, but it's okay to put the 1 in as well because technically 1 is a single power as well. 1 is 1 to the power of 1. Next one, combine laws, right? We've got 2 different laws going on here. Remember back when we did some review, we talked about this operation right here, this line that looks like a division symbol or a fraction line. We talked about that functioning as separating the numerator from the denominator as if they had their own sets of brackets around them. So the first thing I have to do is look at the numerator. I have to do the numerator first, order of operations. So my numerator is 7, let me put brackets here, okay, 7 to the power of 3 plus 2 because I'm adding that. And I'm going to do my denominator in a second, just hang on. Let's get the numerator cleaned up first. This gives me a numerator of 7 to the power of 5 over 7 to the power of 4. So what is that? So now I'm going to combine, I'm going to put them together, these two. Now I can go on to my next step, which is going to be division. Let me switch back to green there, sorry. Division. So that's 7 to the 1 base is 7. That's the same base, 5 minus 4. That's 7 to the power of 1, which you can also write as 7 if you want to. Okay, one more on this page here. We've got a lot of stuff going on here. So I'm going to teach you canceling. Some of you already know it, and that's great, but not all of us do. So before I start looking at my numerator and bringing everything together here, I could do some canceling. Now you don't have to, but it makes things a little bit easier. So let me erase these brackets. Canceling means if you have anything from the top that divides evenly into anything from the bottom, and I'm just talking about the coefficients, that's the numbers here. I'm just looking at the 16 and the 2 and the -8. So instead of multiplying my numerator and getting a 32, we're just talking about the numbers, remember, 32 over -8, what I'm going to do is cancel. So let's first look at the 16 and the 8. If I just had these two numbers written out as a fraction, if I just had 16 over -8, I can reduce that because I can divide them both by 8. So 16, I'm canceling it out and turning it into a 2 because I'm dividing it by 8. And -8, I'm dividing by 2, and that's going to be just, dividing it by 8. 8 divided by negative 8, so I'm dividing them both by 8, dividing them both by 8. That's a negative 1. So I can do that to help me simplify my numbers if I want to, especially when they're big numbers. These ones aren't too bad. I could have gone ahead and just multiplied, but I just want to show you that step here. So let's get back to our numerator. So looking at our numerator now, for my coefficient, I've got a 2 and a 2 left. So in my numerator, just my numerator, I've got a 4. Because I'm multiplying, there's a multiplication symbol in the middle there. So I've got a 4, that's my 2 and my 2. And now let's look at the A's. With the A's, I've got, and let me erase this red box here. With the A's, I've got an a to the power of 2 and an a to the power of 3. So those bases match. That means I can use my power laws, a to the power of 2, and the sign in between them, of course, is multiplication. A to the power of 2 times a to the power of 3 is a to the power of 2 plus 3. Or you could just put a 5 there, but I'm not ready to skip that step yet. So a to the power of 2 plus 3. Now let's look at the b's. I've got b to the power of 5, and that's just a single b there, just a b. b to the power of 5 over b. So my b's are going to be b to the power of 5 plus 1, and that's my numerator. My denominator, what I've got there, remember I've got that negative 1, and then I'm just leaving that alone, a to the power of 5, b to the power of 2. Remember over here just to the left, we just left the denominator alone first while we worked on the numerator, so that's what I did here too. So let's clean this up. This looks kind of messy right here. Remember also we've learned that we can't have negatives in the denominator. We wouldn't really have to worry about that until the very end, till the answer, but I'm going to move it up now. So instead of 4 over negative 1, I'm just going to make that a negative 4. So my next line is going to clean up the numerator here, and that's a negative 4, a to the power of 5, b to the power of 6 over the 1. It's kind of an invisible one. I'm going to put it there to kind of dot it to show it's invisible. I don't have to write coefficients of 1. A to the power of 5, b to the power of 2. So now we're back to, we've tidied up the numerator, and now we're going to look at the quotient laws because this is division. So we've cleaned up the whole numerator here. So now I can go with these a to the power of, these a's have matching bases, so I can put them together. And these b's have matching bases, so I can put them together. Now the interesting thing about the a's is they are exactly the same. A to the power of 5 over a to the power of 5. So I can actually just cancel them right out because they're exactly the same. And I'll put over here on the side that a to the power of 5 over a to the power of 5, that would be equal to a to the power of 5 minus 5, because remember our quotient law, which is a to the power of 0, which is 1. So that's why I can cancel them out, and I'm going to turn them both into 1s. They're exactly the same. Back to our coefficient. Our coefficient is a negative 4. It's a negative 4. We don't have any a's left. What about the b's? We've got some b's left. So we're going to subtract these b's because we're doing division. 6 minus 2. And on our denominator, so this is gone now. My denominator, this 2, I brought it up here with the 6. The a is gone, so we don't have to worry about that. And this was a 1, and I got rid of, I don't have to write 1s divided by 1. So all I had left was the b to the power of 2 in the denominator, and I brought that up by subtracting it. So I don't have a denominator anymore. What I have is negative 4 b to the power of 4. That was the most complicated one, so that might be one that you want to back up the video and start it from fresh all by yourself and see if you can do it and see if you get negative b to the power of, negative 4 b to the power of 4. Last slide, last example. Simplify, then evaluate. So this is the first time we were told we actually have to get the final answer. We're not going to leave it as a power. And we try to do as much as we can without our calculator. You will get questions in your homework that might be like, 6 to the power of 12, well, you're going to need your calculator for that. But on a test or evaluation, if I tell you you may not use a calculator, then I'm not going to give you 6 to the power of 12 to do. So let's take a look at this question first. What do we do first? Well, they've all got the same base, so that's a great start. They've all got the same base, that means I'm going to get to use my power laws. Now I've got this big operation symbol here, division or fraction, and it kind of separates the top from the bottom. So I have to follow BEDMAS, and I have to do the brackets first. And in this case, inside the bracket, inside the little brackets are -2s, there's nothing I can do with that. But inside the denominator, I need to do that first. That's going to have to be what I do first, is the denominator. So let's rewrite the numerator just with the -2 to the power of 5 over. Now the denominator, I've got a -2 twice, so I'm only going to write it once. I've got the same base, so I'm going to write it once. I'm going to use my power laws, and this dot is multiplication. So I add my exponents. 2 plus what? What am I going to add? 2 plus what? I don't see an exponent over here. But of course that's an invisible 1. So cleaning that up, I get -2 to the power of 5 over -2 to the power of 3. Now I have taken care of the b in BEDMAS, and I'm working on the exponents, right? The exponents laws are what I'm doing next. So the exponent law that I'm going to deal with here is the quotient law. So you need to memorize the product law and the quotient law. Quotient law tells me that when my bases match, as they do here, I only need to write the base once. There it is. And I subtract the exponents because we're dividing those common bases. So that gives me -2 to the power of 2. And looking up the question, it said simplify. I did that. And then evaluate. So I have to evaluate my final answer. What is -2 to the power of 2? So that is the same as writing -2 and the brackets out twice because the exponent's touching a bracket. -2 times -2 is 4. So there's my final answer for our last example. So I'm just going to show you, this is the first time I'm showing you this. I have all teachers in every course in high school and elementary school have expectations they must meet. So in order for you to get a grade 9 academic credit, I have a whole bunch of curriculum expectations for you to meet. And one of them is that you have to derive the exponent rules for multiplying and dividing. Derive, that means you have to come up with it. We have to come up with it ourselves. I can't just tell you, here's the power law. The power law is x to the power of a times x to the power of b equals x to the power of a plus b. That would be me just, it would be as if I just said, here's a rule, memorize it. Then there's no understanding behind it. There's no comprehension. You don't know why that's true. Why is that a rule? So we derived that rule together. I showed you why it was true. And in academic, that's one of the differences between that and applied. In applied, we can often just give you the formula. Here's a formula, use it. But in academic courses, you have to understand where the rule comes from and why it's a rule. Like, why is the Pythagorean theorem a squared plus b squared equals c squared? What is that, right? Do you just have it memorized, or did you learn at some point why that is the rule? So that's just a little kind of bit of background into the course that you're taking. You have to be able to come up with the understanding for why these rules are, these laws are the way they are. We have to derive them, not just be able to apply them. So we have a lesson in under 25 minutes. That's pretty good. I try not to make them too long, and too long would maybe be an hour, which what they will be as you get into higher grades, but most of yours this year won't be that long. So you've got homework questions to practice. You can use a calculator if you get, there's some specific ones that I've put on your handout. You can use a calculator because the numbers get really big. And don't forget to always check your work with the back of the book, because it's really frustrating to do all your homework, think you're doing it right, and not find out until you've done like an hour of homework that you did it all wrong. So start checking right from the beginning. And as always, please let me know if you have any questions.